what happens with age is, I told you, your T cells go into this organ called your thymus to develop. With age, we start seeing a shrinkage in this organ. We start seeing architectural changes inside that. And as a result, these number of T cells that are leaving your aged thymus start declining. And what this means clinically is that older adults, they have fewer naive or new T cells. These are very important in fighting off infections they've never seen before, and the ability to do so declines. This might be one of the reasons why we saw a disproportionate response in older adults during the pandemic, because they were exposed to a new pathogen which they'd never seen before, fewer of these naive T cells. But what you might think is that that's fine. They don't have enough of the naive T cells, but on the contrary, we see a buildup of these memory T cells, which have seen pathogens before. So if we re-encounter pathogens, that should be okay. Unfortunately, we start seeing functional changes here as well. So although you have more of these memory T cells, they're not necessarily as functional. And one of the key defects we start seeing there is their ability to expand and proliferate when they are re-exposed to a pathogen. So firstly, what we were interested in looking at in our study was, I told you earlier on, we split our older cohorts into those with low microbial translocation and those with high microbial translocation. What we have previously reported, so we are not able to actually look into the thymus of human people. So what we can do is, again, relying on surrogate markers, we can look out for those T cells that have just finished their development and come into circulation. And the levels of these are known to decline with age. But what we saw in our study was that we only see a significant decline in these recent thymic emigrants that have just finished their development and come into circulation only in those older adults that have higher microbial translocation.